Okay, it's time to get started on SQL proper. Queries, updating, etc., etc. But before we do that, I'd like to introduce the sample database that we'll be using throughout our discussion of SQL. And it's on a subject dear to my heart, beer. So we're interested in beers, obviously. Beers have a name, beers have a style, IPA, lager, pilsner, whatever, and all beers are obviously made by a brewery. Beer drinkers, this is a database about beer and the people who drink it, obviously. Beer drinkers go to bars and hotels to drink beer. The bars and hotels they go to sell a range of beers, and the prices may vary from one bar to another. So one bar might sell a particular beer for $5 a pint, and another bar might sell it for $6 a pint. Drinkers have beers that they like, and they have some favourite beers. We're not going to distinguish the favourite ones from the ones they just ordinarily like. So there are a lot of things that we could have added to this database. Could have put the alcohol rating of the beer, the actual rating, how much you like it, rather than just the fact that you like it. Could have added tasting notes, could have added notes on additions to the style. And of course, despite what you may be thinking, this database is not autobiographical of me. Right, so given those requirements, I sit down and draw up a schema. This is similar to schemas I've used in the past, but there are a few changes, so be careful if you're using old notes. All right, so you have a beer entity, a drinker entity, and a bar entity. Beer has name, brewer, and style. In this database, we're going to be using names as primary keys. That makes the queries a lot simpler. I'll introduce another database later that uses the sort of standard ID as the primary key. One side effect of things like this is that we can't have two beers with the same name. Now that's actually not true in the real world. There are quite a few beers that have similar names. Drinkers, and you can see the same, we're using name as the primary key for the drinkers. Once again, that forces us to have all the drinkers to have different names, and similar with bars. That's kind of more plausible. But of course, these names are going to be strings, they're going to be fairly long. If they're used as primary keys and foreign keys, they occupy more space in the database. And frequents obviously has to relate drinkers to bars, therefore it's going to contain a drinker name and a bar name. Similarly with cells, similarly with likes. Notice we've got all end-to-end relationships, and we're not being fussed about participation. I mean, if you really wanted to be fussy, you might say not much of a bar if you don't sell any beers, but this schema allows for that. And similarly, you're not much of a drinker. Well, maybe you are if you don't like any beers. Okay, is there anything else to say about this this design? Probably not. So we're going to use this design as the basis for coming up with a relational design. This is very standard. So you can see that all of the relationships have turned into relations. Obviously, they're going to have primary keys to the two tables that they relate. The only one that's slightly more interesting is the cells relation. It relates a beer to a bar, but also specifies the price of that beer at that bar, which of course is the thing that allows different bars to sell the same beer, well, to sell beers for different prices. Alright, bar, drinker and beer are pretty much very straightforward mapping. So these extra tables are mappings of the end-to-end relationships in the ER schema. Alright, turning that into an SQL schema, what we need to do is get more specific about types and be a bit specific about primary and foreign keys, although all of those primary keys are underlined, foreign keys, you can see they have an arrow coming out of them. So they're implicit in that database, but here we, in that diagram, but here we make them explicit. All right, one thing that's useful when you're designing SQL schemas, if you've got a data type that's used as both a primary and foreign key type, it's very useful to give it a name so that you don't have a problem of potentially defining beer names to be varchar 50 in the beers table and then defining them to be varchar 40 in the cells table, which means you could potentially have valid beer names that you can't use as foreign keys in the cells table. So just using names for particular types is just, a useful form of abstraction. So here we're assuming beer names can't be longer than 50 characters, bar names can't be longer than 30 characters, and drinkers have very short names. And as we'll see, we're actually only using first names. Alright, so I don't think there's anything unusual here except for the fact that we've used the beer name type or the beer name domain to define the name attribute. We're insisting that we know who the brewer is, so we've put a not null on that, but we're not fussed if we don't know what the style is. So there's no not null, so you're allowed to have null styles. As long as the beer's got a name and the name has to be unique, and as long as we know who the brewer is, we're happy with beer tuples. Bar tuples, we have to know the name because it's primary key. We don't have to know the address, but it's important that we do know the bar's license number. Now you can argue about the address. Maybe we need to know that as well. The drinkers table, notice that we're using these domain names. So drinker name is used here, and we know that's actually varchar 20. All right, we need to know the drinker's address, I guess, so we can send him home if he rolls out of the pub dead drunk. And we need to know the phone number, so we can phone home before we take him home. So in this case, both of these are not null. As I said, you could definitely argue for the fact that we ought to know the address of a bar, but I decided not to. Alright, so the tables that are all based on relationships have kind of obvious structure. They've got two foreign keys which together form a primary key, and in the case of cells they have the additional attribute which gives the price of that beer at that bar. I've used float here, I could use currency, sorry, not currency. Postgres doesn't have currency, it has money, so I could have used the money type here. Notice that these foreign keys are defined using the appropriate types, therefore we're not going to have any problems of the type I mentioned before, that a bar name mentioned, or that a bar name mentioned here can't exist in the bars table. The foreign key is going to force that, but if we had the wrong type, if we had the wrong varchar length, then that would potentially cause problems as well. So the likes table, that's very straightforward. Two attributes with the appropriate types. Together they form a primary key. And the basic reason for this is we don't need to say more than once that John likes VB, even though that's patently untrue, But once we've said John likes VB, there's no point having another tuple. It also says John likes VB. So the combination of drinker and beer should be unique, and it should be the primary key for this table. And of course, the primary key is composed of 2 foreign keys. And finally, the frequent table is how you meant to pronounce that. Once again, two foreign keys that combined form a primary key. Right, so hopefully that SQL structure is pretty straightforward. All right, so let's have a look at some of the actual data. All right, so here's a sample taken from the beers table. The other thing I should have mentioned, that all of the table names are pluralized, or at least all the entity table names are pluralized. So we've got beers here, whereas here we had beer, and similarly in the ER diagram. It just so happens that all of the relationship names happen to be kind of pluralized already. They sound plural even though they don't have to be. Right, here's the first 15 beers in the beers table. So get all the information. Star means all attributes. If you don't understand this, don't worry. The point of the next few videos is to explain all this stuff. But we're ordering by the name, and we're just taking the first 15 beers from the table. So you can see we're only up to B, so there's a fair few beers available. All right, the drinkers table. So here just 6 drinkers living in various places and having various phone numbers. I hope I haven't got any duplicates there. So this is all very contrived, this data. Similarly, the bars is a very small subset of the bars in Sydney. I hope none of these have gone broke since I made the database. I don't think they have, although the local tapas might have changed its name. Right, so once again, they've got an address. In this case, the address is just a suburb name. So we can have multiple bars in the same suburb, like the Australia Hotel and the Lord Nelson, both in the Rock. And we've also got license numbers for each of the bars. So you can see that none of the attributes are actually null in our data, even though some of them are allowed to be. All right, so let's just jump back. So this is the database that we'll be dealing with. So when we're asking queries and so on, it's also always useful to keep this in the back of your mind. That's one reason why ER diagrams are actually useful, because they can give you a map of the database as you're trying to ask queries on it. Okay, so that'll do for the sample database.